Hi, it's Tim from Morethan.Technology. Lately I've spent a lot of time debugging skills in agile teams, so it's actually quite refreshing to work on something more technical. I recently attended JeffConf, a serverless conference in London, which was fantastic. It was great, but there was a worrying message from the developers attending. When things go wrong, how do you diagnose them? What tools do you have? The standard response seemed to be to add more logging. And while logging is fine, it's a very primitive solution when we have years of advancements in computer science. So I decided to dust off a language from the 1970s, a favorite of mine, called Smalltalk. It's still going strong, and it's still got lots to teach us today. So let's look at my little project called PharoLambda, which is about how to run Smalltalk code on AWS Lambda. But the piece I'm really excited about is how Smalltalk can debug Lambda sessions. We'll take a look at that in a moment. So first, let's have a little look at my simple Alexa skill that I've written in Pharo that is running on AWS Lambda.
Alexa, ask Pharo hello.
Good afternoon. It's 14:21.
Okay, so that's a Smalltalk skill running on Lambda. If we look at what's going on behind the scenes, if I now swap back to a web browser, we can see the Lambda console, and we can actually test our application in code. And you can see we get a result back, and we see some log output, and we can see it took about 800 milliseconds for my skill to execute. Now the interesting thing, and this is a real case scenario, is what if we test a more complicated Lambda skill? So the console's got a few different skills to try, so let's pick one here called an intent answer. And if we save and test that, an interesting thing happens. Oh dear, I seem to have an error, and I've got a stack trace coming back. But what's interesting here is you can see that in that stack trace it says serialized context, and it talks about an S3 store. So if we go to my S3 bucket and have a little look at what files are in there, there's an interesting file called pharodebug.fuel.zip. This is the interesting piece, because PharoLambda has actually serialized the execution context of its application and saved it into that bucket. So we can actually now flip back to our Pharo environment. And I just want to briefly show you an interesting feature. Here we've got an S3 library and a bucket method. If I evaluate that, I can actually see the name of a bucket, and I can also list the contents of a bucket. So here you can see that I've got a number of files, and I can actually drill down inside those file objects and visualize them. This is called GT Inspector, and it's very cool. Anyway, armed with the ability to access S3, Lambda's got a useful convenience method that lets you debug a saved S3 session. So basically, it retrieves that zipped fuel context and actually rematerializes a debugger. So here we're looking at a debugger which is resumed from the period where we actually had that error. So if we look down the stack trace, we can actually see there's our process method. But it doesn't stop here actually, because what we can actually do is restart execution. So we can actually pop down in the stack and then start to step over and see what actually happened that caused our error. So if we keep stepping over, right, here we've hit that parsing error. So that's interesting. So let's go back a little bit again and have another look at it. I missed that one, so we can restart again. And actually it's occurred to me that let's just look at the string that we've got. So actually in our process.json file, we seem to have a string that doesn't have the beginning. So if I inspect that and just have a little bit more of a detailed view, yes, there's something interesting there. Something has caused this string that was the parameter that was passed to get truncated somehow. So if we close that inspector, we can actually drop back and see, okay, so there's the process, there's where we were initially called, and we still were getting this truncated string. At this point, the penny drops, and I think we go back to our JavaScript shim, and we look at where we're calling Pharo, and we're actually converting a string to JSON and sending it as a parameter to Pharo. However, what we've neglected to do, and this is probably where there's a missing test on the JavaScript side, is we need to back quote a Smalltalk string. So here's a piece of code that I've done. I'm just bringing it back into place. Basically, we do a regular expression to replace a single back quote with a backtick back quote. So that effectively escapes a Smalltalk string, so that actually when we read it in on the Pharo side, it won't get interpreted as different two different strings. So we can actually commit that. So this is interesting. So because Pharo has now embraced Git rather than using a closed environment like Smalltalk traditionally had, we can actually commit that code back to the repository along with all of our Smalltalk code that's stored in there. And actually we've got a build pipeline in GitLab, and I'll quickly show you that. I'll whiz through, I'll do a fast forward so that you can quickly see it building up. So we first create a brand new environment. We then load the code and zip up the result. And finally, we deploy that zip file and upload it to Lambda. So then we get to our environment in Lambda, and we can actually test what we've just uploaded, and we can see now we've got a successful execution. Took about a second this time. If we go back and look at how this actually happens, the error handling, it's actually quite simple. In Lambda runtime, I've got a quit with message. This is called when there's an error in the Smalltalk environment. And basically what we do is we write a context with a library called fuel. And effectively, fuel serializes the context. So it creates a serializer, and it actually writes that out to a stream. And in this case, we use a zip stream, so we keep it nice and small so that we can upload quite quickly. And then we just store that zipped stream of bytes into a bucket on S3. And then to actually get it back, if we look in the development mode, there's a extension method called debug S3 session, and it does the inverse. Basically, we create we access our bucket, we create a zip stream, we bring the bytes into the zip stream, and then we materialize from that zipped stream. And then we can actually create a stack debugger and pass it the materialized context. And then if we just execute that again, basically it does those steps and pulls up the debugger again. So that's actually all I wanted to show you about PharoLambda. I would like to call out the Pharo consortium and all the folks that contribute to Pharo. It's an amazingly productive environment. It's got a lot of cool tools. This is just scratching the surface. I hope this inspires you to think about the tools that you use for debugging serverless applications. I think everyone should be able to do this in their language of choice. I also hope this screencast will inspire you to try Pharo Smalltalk yourself. It's a fun and productive way of programming. Anyway, whatever your language choice, stay safe.